expression for total resistance of two parallel resistors. Let us derive the total resistance of two parallel resistors whose resistances are R1 and R2. We know that the total resistance is given by 1 over R equals 1 over R1 plus 1 over R2. On the right-hand side, we have the sum of the two fractions, 1 over R1 and 1 over R2. We can make the denominators the same by multiplying and dividing the first fraction by R2 and by multiplying and dividing the second fraction by R1. They become 1 times R2 over R1 times R2 and 1 times R1 over R2 times R1. Since the two numbers now have the same denominator, we can add the two fractions easily. 1 times R2 over R1 times R2 plus 1 times R1 over R2 times R1 equals 1 times R2 plus 1 times R1 over R2 times R1 equals R1 plus R2 over R2 times R1 equals R1 plus R2 over R1 R2. Therefore, 1 over R equals R1 plus R2 over R1 R2. Taking the reciprocal, R equals R1 R2 over R1 plus R2. This is the product of the two resistances divided by the sum of the two resistances. Note, however, that this formula is only valid for two resistances. We can verify this result by substituting the values from the previous problem. R1 equals 3 ohm. R2 equals 9 ohm. We found that the total resistance of the parallel combination is 2,25 ohm. Using the expression for total resistance of two resistors as the product of the two resistances divided by the sum of the resistances, R equals R1 R2 over R1 plus R2. R equals 3 times 9 over 3 plus 9 equals 27 over 12 equals 2,25 ohm. This is the same value that we obtained earlier.
Starting to feel it? Now go master it with Messi.